So today's lesson is lesson 2.6, formula. Today we're going to talk about manipulating literal equations. A literal equation is any equation involving two or more variables. Example, 3x plus 7y equals 24. Or more currently, we have been working with p equals 2l plus 2w, the formula for perimeter. To solve a literal equation, you solve for one of the variables in terms of the other. Get the variable you are solving for alone on one side of the equation. Example number 1. Solve the formula for the volume of a rectangular prism, V equals length times width times height, for width. So, I'm solving this formula in terms of W. I'm finding or solving for W. So the first thing I need to do is get W all by itself. I'm trying to isolate this variable. So the first thing that I see is I have L and H multiplied by W. The undo of multiplication is division. So I have to divide both sides by L times H. When I do that, the L's and the H's cancel out over here. So I have V divided by L times H equals W. That's done. Example 2, I have V minus VR equals P for B. I'm solving this equation or this formula in terms of B. V minus VR equals P. And I know that you're probably thinking, well, what does that equation mean? It really doesn't matter. It's kind of like, who cares? You don't really need to know what this formula is used for. You just need to know how to isolate the variable P. So the first thing that I see is if I'm trying to isolate this variable and I cover it up, I see that I have to move away this positive Z. So the first thing I will do is subtract Z from both sides. Now I have negative B times R equals P minus Z. Alright, that negative B times R, that's the same thing as B times a negative R. It's actually this negative over here next to the R. So if I divide both sides by negative R, I will get rid of that negative and the letter R. So I'm going to divide both sides by negative R. When I do that, the R's cancel out instead of the negative sign. And I'm left with B equals the quantity P minus Z divided by negative R. I don't know if you guys remember, but when we first started talking about fractions and solving equations, I asked all of you to remember to always put the negative in the numerator, not in the denominator. So I'm actually going to rewrite this as B equals negative times the quantity P minus Z all over R. Alright, let's try another example. Example 3 asks us to solve the formula for the perimeter of a rectangle. P equals 2 times the quantity L plus W. And I'm trying to isolate the W, solving for W. Okay? So the first thing that I see is that I have 2 times this quantity. So I have to divide both sides by 2. And when I do that, I have P divided by 2 equals L plus W. I'm trying to get W all by itself, so I need to subtract L from both sides. When I do that, I have P divided by 2 minus L equals W. Okay? Let's do another example. Oh, this looks like a linear equation. 2x minus 8y equals 16, and I'm solving for y. We spent months solving for y in pre-algebra. Solve for y. So equation 2x minus 8y equals 16. First thing we do is subtract 2x from both sides. So I have negative 8y equals negative 2x plus 16. Notice that I put the x term first. So when I'm finished, this is going to model the equation y equals mx plus b. Hopefully saying that you guys all know what I'm talking about. Y equals mx plus b. I need to divide everything by negative 8. And I need to remember to divide every stinking term by negative 8. When I do that, I'm left with y equals a negative divided by a negative is a positive. 2 over 8 reduces to 1 over 4. X 16 divided by 8 is 2. A positive divided by a negative is a negative. So when I solve for y, I have y equals 1 for x minus 2. And for those of you that can't remember what y equals mx plus b stands for, that means that if I were to graph this, my equation would have a slope of 1/4 and a y-intercept of negative 2. That's just a reminder. It's not important about this lesson, but just this is an FYI in case you can't remember. Okay? All right, our last example. You can actually use the number of chirps a cricket makes in 1 minute to determine the temperature. So, the formula for that is F equals the quantity N divided by 4 plus 37, where N is the number of chirps. All right, so the question is, how many chirps per minute can you expect if the temperature is 60 degrees? So F equals N divided by 4 plus 37. Well, the first thing that we're going to do is we're going to solve this equation in terms of N. We're going to solve this equation in terms of N just because that's what this whole lesson was about. Okay? So the first thing I need to do is subtract 37 from both sides. Once I have that, I have F minus 37 equals N divided by 4. Cancel out. Well, what's the undo of divide? The opposite or the undo of N divided by 4 is to multiply by 4. So I'm going to multiply this side by 4 over 1. I'm going to multiply this side by 4. So when I do that, I have 4 times the quantity F minus 37 equals N. Now remember, I'm trying to solve for N. I want to know what the temperature, or I want to know how many chirps I can expect, how many N, when the temperature is 60 degrees. So now I'm going to let F equal 60 degrees. So let the temperature in degrees Fahrenheit equal 60. So basically, I'm just going to plug it in. 4 times the quantity, 60 minus 37 equals N, the number of chirps. 60 minus 37, 23. And 4 times 23 is 92. So when it is 60 degrees outside, I can expect to hear 92 chirps per minute. Okay. All right, that's it. So your homework for this evening is on page, starts on page 113, 6 through 42 even. And then I also would like you to do number